Tato, welcome to this Infrastructure New Zealand online event on low emission vehicle infrastructure. I'm Claire Edmondson, the General Manager at Infrastructure New Zealand, and joining me hosting this event is Wei Lu, who's the Head of Investment Banking and Asset Management from our event sponsors, China Construction Bank. We're very grateful for their support. So low emissions vehicle infrastructure is a very current cutting edge topic, and we're thrilled to have more than over 400 registrations for this event and the high caliber of presenters I'm sure we're all looking forward to hearing. So I'd like to pass over to Wei to just do a few housekeeping matters.
Thanks, Claire. Tina Kato, Nami Hinui. Good afternoon, everyone. I'm Wei Lu, Head of Investment Banking and Asset Management from China Construction Bank in New Zealand. For those of you who is not very familiar with CCB, we have been present in New Zealand over 7 years. Although infrastructure has come with our genes as the name of Construction Bank, we have a full banking functionalities, not much different from other banks in New Zealand. Being green has also become part of our genes, from launching Global Green Bond Index in Luxembourg to participating in green lending in New Zealand. When we were planning this event early this year, we expected to welcome you from our office. However, as we all experienced the current COVID pandemic, we have to switch to the virtual event. In a way, I'm glad we are able to host this event online. This has given us the opportunity to open this discussion to all of you today, not only across Aotearoa, but also other parts of the world. Adopting and adjusting our working and living style has become a new norm for all of us. In the last few years, I was able to travel between New Zealand and China quite frequently from my work. One thing that really caught my eyes was that the rapidly growing numbers of electric vehicles driving in different kinds and different brands on the street of China, and the massive scales of different types of charging facilities. The changing dynamic was not year by year, but month by month. Earlier this year, New Zealand government has announced the Clean Car Discount policy. It was a great initiative and the first step of achieving the goal for fossil fuel vehicles by 2035 and the goal for emission zero by 2050. Today is a great opportunity to hear from our panel experts and the Minister of Transport on this topic. Before I'm going to introduce our speaker from the other side of the Pacific, I'd like to explain how we are going to run our Q&A session for you. We are going to use Slido for our Q&A session, and the details are at the corner of both my background and Claire's background. Our first Q&A session will be opened right after our last panelist has finished his presentation. Our second Q&A session will be opened after Minister Michael Wu's speech. We'll monitor the questions coming through on Slido and put them to the appropriate presenters at the Q&A sessions. Now it's my pleasure to introduce our panelists from 36KR Global and Huawei. 36KR is a Nasdaq-listed technology media and consulting company in China with more than 100 journalists and more than 800 million page views per month. Its global footprint has reached across Pan-Pacific, including New Zealand. Liam Gorky, the director of 36KR Australia and New Zealand, has kindly invited Alex Zhao, head of global research 36KR from Beijing today. Alex leads the in-house research and the consulting arms of 36KR Global. His team provides international clients with industry analysts and customized research service focused on the China and wider Asian markets. Given the strengths of China's EV industry, Alex has a deep focus in EV companies and the industry. Before joining 36KR, Alex was an associate vice president with Hong Kong Stock Exchange and an investment banker with Credit Suisse, specializing in TNT. Also, we are glad to have Mahesh Chandra, Senior Solution Architect from Huawei Digital Power. He is responsible for driving worldwide business development and innovation and strategy of digital power. He has more than 17 years of experience in management roles, business development across Latin America and Asia Pacific, and recognized as a trust advisor in the business and engaged in carbon neutral discussions with numerous regulators and third parties. Now I will pass to Claire to introduce our speakers from New Zealand. Claire, over to you.
Thanks, Wei. So it's great to have, we've got Richard Hobbs, John Worth and Derek Copper here. So Richard Hobbs is a General Manager Strategy and Customer at Transpower, where he's in charge of developing and implementing Transpower's strategy. Richard led work on Transpower's Empowering Our Energy Future, a March 2020 report setting out the generation and transmission investment needed, along with 10 essential steps required if Aotearoa New Zealand was to embark on an accelerated programme of energy sector decarbonisation. Prior to joining Transpower, Richard was based in Sydney, where he worked at Sparks Infrastructure's investment manager, and he has previously held roles at the Boston Consulting Group, Bloomberg, New Energy Finance, and the Australian Government's Clean Energy Regulator. We've also got John Worth. He's Geo40's Chief Executive and Managing Director and has significant global experience in renewable energy development and operations across wind, wave, solar, and geothermal. So under John's watch, Geo40 has proved it can manufacture high quality, ultra low carbon silica products and has achieved significant success with its nascent direct lithium extraction technology, proving it can recover lithium from a range of global fluids. John is positioning Geo40 as a preeminent solutions provider in the sustainable recovery of future minerals from fluids, creating new value in the geothermal ecosystems in doing so. We've also got Derek Copper as Auckland's Transport's Metro Decarbonisation Manager, and he is leading the transition to a zero emission bus fleet known as Auckland's Low Emission Bus Roadmap, which was a low carbon future award finalist at the 2021 New Zealand Energy Excellence Awards. The roadmap included technology trials with low emission buses and charging infrastructure, and played a critical role in deploying 33 battery electric buses in Auckland and the country's first hydrogen fuel cell electric bus trial. Derek chairs the New Zealand Low Emission Bus Working Group and is a member of the National Bus Public Transport Decarbonisation Steering Group, who works collaboratively to bring a greater understanding of the challenges and benefits of moving to zero emission fleets, playing a key role in supply chain development, supporting the transmission from diesel to electric and hydrogen fuel cells in buses and ferries, including charging infrastructure. So as Wei said, when we finish this panel with a Q&A, we'll be hearing from the Minister, the Transport Minister, Michael Woods, and that will be roughly about 5:20. So welcome, gentlemen. We're looking forward to hearing from today, and let's start the presentation with John.
Thank you, Claire. I'm delighted to, I guess, tell the Geo40 story today, and I'll share a couple of pictures as I do so. We do two things at Strong. Believe not have a sustainable future without sustainable future minerals, and I'll explain what that means. And we bring a lot of value in the geothermal ecosystem. So we talk about having a dual mission. The photo on the left there is the infamous pink and white terraces destroyed in the 1886 eruption of Mount Tarawera. And that is effectively what we do in our plant. We replicate that natural process, and we do that by bringing together a very diverse suite of experts across process engineers, mechanical engineers, minerals experts, metallurgists, and so on. In terms of what we've achieved so far as a business, I guess we are in our essence, experts at going from the lab to the large-scale plant. So the photos along the bottom of the screen there, I guess, are this journey in action. So we start off in the laboratory with an idea. We then move to a containerized pilot plant. We have 2 of these. One lives in Japan and one lives in New Zealand. The middle photo, 10 times that scale again, is a demonstration plant for silica recovery from geothermal fluid that we've had running for about 3 years. And on the right is the asset we commissioned in February, which I'll show you later, which is a genuine world first. An obvious question, what exactly is colloidal silica and why do we pull it out of geothermal fluid? It's an extraordinary nano material that goes into everything from batteries to paper to low carbon concrete to paint. And it is, I guess, at its essence, an extraordinary natural nanoparticle. So we make a range of particles that vary typically around 4 or 5 billionths of a meter in diameter. And they have very unique physical properties. Just in terms of silica in the geothermal environment, silica blocks pipes. Anywhere you find geothermal power generation, you will find silica and you will find blocked pipes. If we can take that silica out, which we do, that opens up more of the heat in the fluid to be utilized for power generation. It also opens up the opportunity to sequester carbon dioxide emissions, which can be significant in the geothermal power space. So we think that that's what we mean by innovating in the geothermal ecosystem. Silica really is the gateway drug to doing good things in geothermal. And that's a schematic for how that works. In a typical environment, we can permit about 10% additional power generation. And taking the silica out is also important because it allows us to access some of the other minerals that are present in geothermal fluid. We have completed the first row there. We have what we call our Ohaki Northern plant. That'll do about 7,000 tonnes of silica for sale into global markets. We're already shipping that product to as far afield as Mexico, Japan, Asia Pacific and Europe. We have another development agreement already in place to expand that plant, and we're looking at a couple of big plants. So we're on a fairly relentless journey towards being a $100 million revenue business. Just in terms of other minerals and geothermal fluid, the geothermal environment is very interesting in that you can find all sorts of extraordinary future strategic minerals in geothermal fluid. We've talked extensively about silica, but what's prescient about today's conversation is, I guess, the presence of lithium in geothermal fluid and the role that might play in an electrified future. We have a process to recover boron from geothermal fluids, another industrial mineral that's highly valued. And we're at the early stages of recovering cesium, which is the stuff in your touchscreen, and antimony, another strategic mineral. And I think what excites us in terms of where we are right now is there really isn't a global sustainable source of lithium for the EV transition. And we plan to play a significant role in that space. Let's talk a bit more about lithium. That's the theme of the day. And one of the Reuters journalists called it the commodity winner that money can't buy. That's a pretty complex space. At Geo40, we've developed our own direct lithium extraction technology. We've been working very hard on that over the last couple of years. Over recent months, we've filed a number of patents. We've done lithium recovery work from brines out of South America, Europe and New Zealand. We've achieved very high recovery rates, and we've got an extremely ambitious forward program, which will roll out over the next 12 months. And some of the big players in the market are now starting to compare us to, I guess, the company that's probably the market leader, a firm called Lilac Solutions. And there's a nice linkage there. We both have Bill Gates, Jack Ma and Jeff Bezos's climate change investment vehicle, BEV, or Breakthrough Energy Ventures. We share them as an investor. So I guess we're starting to get a little bit of traction for what we're trying to do. I mentioned earlier that what we're about really is going from the laboratory as an idea to a full-scale commercial operation. And what you see on the screen now is the world's first large-scale sustainable geothermal colloidal silica from geothermal fluid plant. Nobody else has done this anywhere on the planet. Many have tried. And what is exciting about Geo40 at the moment, I think, is the idea that we can replicate that journey. Different technology, but the same skill sets, but go on that exact same roadmap, but with lithium. And that's what's certainly what's keeping us up at night. So that was really all I wanted to say. That's the role we think we can play in decarbonisation. If we can provide a really sustainable source of lithium using Kiwi know-how, Kiwi tech, and leverage that globally, we think that'd be a pretty good achievement from this glorious little motu. Thank you.
Derek, do you want to go next?
Thank you, Claire, and welcome everybody to this event. A great opportunity to share with you our vision and our transition to a low carbon future. I'll talk to you about our zero emission public transport aspirations and the requirements for charging infrastructure. Okay, so our low emission bus roadmap, as Claire mentioned in the introduction, has become our initiative and tactical plan to transition to full zero emission public transport by 2040. We started in 2018 with trial of 2 battery electric buses, which provided us with the good information in terms of what the requirements are and how they operate. We also have started a number of other trials to understand how the technology perform and what we need to do in order to remove barriers to early adoption of electric buses. In order to do that, we wanted to engage with the industry, and we set up a low emission bus working group that included all our operating partners as well as all other players in the supply chain. Within the last 2 years, we have conducted a comprehensive grid impact study to understand the power requirement by all buses on our network in the future and how we can smooth the peak power demand through overnight depot charging. We have also undertaken better understanding of the requirements for the electric bus infrastructure at various depots, and we have establish what the various interventions and requirements are for the bus operators across various depots. Since then, we have implemented 33 electric buses, both across 3 main services on the links on Waiheke Island, around the airport and in the city, as well as trialing 5 electric and hydrogen fuel cell buses. Our aim is to accelerate our transition and complete it by 2030, subject to funding. So we're going to do it 10 years quicker than we originally set out to do and reduce the greenhouse gas emissions down to about 10% compared to the emission profile from diesel fleet in 2019. We're also working to support the government's bus public transport decarbonisation policy, aiming to transition the entire bus urban fleet in New Zealand by 2035 and achieve the full zero emission public transport across all our Auckland transport modes by 2040. The Auckland transport bus fleet is privately owned. We're working with 9 different privately owned bus operators who are our operating partners. They operate more than 1,350 buses from 22 depots. So those depots require quite a significant investment in charging infrastructure in order to ensure that they can deliver full days work. Those public transport services are very important for us to transition to low emission technologies, as they produced in the last year more than 109,000 tons of CO2 emissions, taking 79% of, contributing 79% to those emissions, with ferry followed by 17%. Our Auckland overnight charging at depot is the preferred charging solution, as it requires less investment across the wide and geographically spread bus network. But it means that with our outsource business model, we are procuring those bus services and charging infrastructure via single service contracts for bus services at the moment. So the electricity supply to bus depot is responsibility of electricity network owner, but the costs are covered by the transit authority like us, and when the lease or capital expenditure costs are transferred by operator. The depot infrastructure is the responsibility of the relevant bus operators, and the buses and charging equipment are also expected to be procured by operator. This is in line with the current public transport operator model that governs the way public transport is funded and operated in New Zealand. Our ferry fleet is also privately owned and operated. We have 9 operational ferries in the fleet with the quite old diesel engines, and they are operated under service contracts with 3 ferry operators. These contracts are coming up for renewal in early 2023, and we have to make some decisions around new vessel characteristics, including power source and charging infrastructure, in order to start the procurement process. On that front, we are working with our partners, EV Maritime, Flawless 360 and Vector Limited, who have been provided some funding from the Crown Infrastructure Partners to trial first electric ferry across Auckland Harbour. We're working with them to enable this through provision of charging infrastructure at our terminals, and also to operate those services on our ferry network. So what are we looking for? We're looking for charging infrastructure for buses. We have implemented charging infrastructure at trials at our Manukau bus station to understand whether or not we would be those locations would support full operation of bus fleet across the entire network. We conducted a grid impact study in collaboration with Vector that shows that 88% of our bus network can be operated by battery electric buses, even when the batteries degrade over time to about 80% of its capacity. But we also have learned from the larger deployment of trial at CityLink depot, where buses were deployed in April, and that deployment provided some key learnings on challenges and costs, as well as we're investigating investment in charging infrastructure at depot to lower operational costs, but also maximize depot footprint to deliver the flexibility and better value for money for both AT and our communities. On a ferry, in a ferry space, we are working with the CIP-funded e-ferry project. We have undertaken similar grid impact study to understand the power demand from the much larger and more electricity-hungry ferry vessels, and we're looking at various charging options and what would be appropriate in the Auckland environment. Future infrastructure options are something that we are interested to explore further, particularly as we may look at the various ways to either help bus operators to make the investment and transition to zero-emission buses or ferries. And we're looking at portable plug-and-play type of chargers for operator depots where infrastructure and hardware can be installed and used for charging. And then when it's no longer required or the existing depot are no longer used by bus operators, they can be relocated to other locations. And we're also looking at other new technology to address the challenges of the additional footprint required at bus depots. So we're looking at potential contactless charging trial, as well as assessing options for gantry pantograph charging at depot to maximize the footprint, and maybe even in the future move into multi-story depot as the city grows and expands. We're also interested in working with Hiringa Energy and some other partners and stakeholders in seeing how the hydrogen fuel cell opportunity presents itself in terms of addressing some of our requirements to meet operational needs, and how we can support and encourage the development of green hydrogen production. We are running New Zealand's first hydrogen fuel cell bus trial in collaboration with Ports of Auckland, who are providing a refilling option for our bus, and they have plans to build on-site electrolyzer plant and refilling at the ports. But we're also looking at other facilities built by others to be used by future bus operators at ferry terminals, bus depots, and any other locations to support their transition. Thank you.
Hi, how's it going? Richard Hobbs here, General Manager, Strategy and Customer from Transpower. I'll just share my screen so that my presentation comes up. Okay. So today I'll be talking about the opportunity for electrification of transport. So why does Transpower have such an interest in transport electrification? Well, as the national electricity grid owner and operator, we need to be able to forecast future electricity demand to understand the infrastructure that we need to provide to enable it. And as a core piece of infrastructure that will be critical to decarbonisation, it's no surprise that we have committed to learning and developing our understanding of how New Zealand's energy future needs to play out to meet our national emissions targets. So here you can see some of the work that we've done. In 2020, released Whakamana I Te Māori Hiko, Empowering Our Energy Future, which outlines high-level future energy scenarios and the 10 conditions for success needed to achieve a highly renewable, low-cost energy future. And then more recently, this year, we released the Electrification Roadmap, which focuses specifically on the electrification of transport and process heat. And it is Transpower's call to action and provides increased detail on the regulatory, commercial, consumer, and policy levers available to kickstart electrification. So I'll talk today about how we're going and then what we still need to do in line with that roadmap. So how are we going at reducing transport emissions? Well, the story is actually not very well. Transport emissions have nearly doubled in the last 30 years in New Zealand, to the point where now you can see they're higher than all other energy emissions combined across industry, electricity, and other uses. So transport now represents close to 40% of the emissions covered under the net zero carbon target, which excludes biogenic methane from agriculture. So a really significant chunk of the emissions that will be needed to be reduced to meet our net zero carbon target. So we need to do something to start bending the curve now. So in Whakamana I Te Māori Hiko, we predict that at least 80% of road transport emissions will be reduced by electric transport by 2050. And I'll outline some of the economics soon that will back this up. And if we want to hit zero emissions in transport, we will need hydrogen and biofuels. But the key message here is that electrification will do the bulk of the change. So in order to achieve these emissions, it is quite important to understand where transport emissions come from in New Zealand. So of the 16.6 million tonnes of transport emissions, 80% come from light transport. That's 60% from cars and motorcycles, and another 23% from light duty trucks. Heavy trucking and buses make up 10%, and aviation and rail and marine the final 10%. So yes, planes are heavy on emissions, but Air New Zealand only has around 100 planes, whereas there are over 4 million cars on the road in New Zealand. So the largest opportunity is clearly in light transport. So what you can see here is an outline of the different fuels that might be applicable to achieving emissions reductions in different transport types. So on the y-axis here, you have the weight of the vehicle. So the higher it goes up, the heavier the vehicle. And on the x-axis, you have the distance traveled. The bubble size here represents the relative contribution to New Zealand's transport CO2 emissions. So down the bottom left, you can see the light vehicles that tend to travel shorter distances. These are prime for electrification. And like I say, these are the light transport options, and they represent 80% of emissions in our transport sector. So that is the low-hanging fruit, and that is where we really need to focus on. There are also, though, many opportunities in other areas of transport, particularly as Derek mentioned, buses, really significant area where we can make changes soon, and also incentivize the uptake of public transport to reduce vehicle kilometers traveled on our roads. But of course, electricity, it's critical, but it's not the only fuel. You can see there that the heavier the transport mode, on average, the less suitable electrification is to a low emissions alternative. So here is our forecast of electric vehicle uptake. So the graph here on the y-axis demonstrates the billions of vehicle kilometers traveled on our roads. We expect that to be relatively flat due to the uptake of public transport. So what you can see here is a rapid uptake from 2025, and this is when the economics for electric vehicles become very compelling. So at the moment, the total cost of ownership has been reached, and then the sticker price parity will be reached, we think, sometime between 2025 and 2030. That's where the upfront cost is the same as ICE vehicles or internal combustion engine vehicles. And this is where also when the secondhand market really starts to grow. We think that you'll have about 20% of the kilometers traveled on the roads will be EVs by the year 2030, and then reaching nearly 50% in 2035. And the 2030s will be really immense. We think we'll go from 20% to 70% by 2040. And while this is the vehicle kilometers traveled on the road, the implied uptake for new vehicles, for EVs, given that a lot of the vehicles stay on the road for many years, is much higher than this to actually reach these overall targets within the fleet. There is also the opportunity, I think, with what we're seeing in countries like Norway, that this uptake could be even higher, and we could have an even more rapid transition towards an electrified fleet that is almost fully electrified by 2040 if we do this well. And here's the exciting news. You know, decarbonizing our economy will also cut our energy bills. So renewable electricity is already the cheapest form of new electricity. And our modeling here suggests that the average household with one EV will cut their total overall household energy bill by 25% and 2 EVs by 50% by the year 2035. So it's a significant opportunity to reduce overall household energy bills. And because of this cost reduction in terms of the operating costs, but also the reduced upfront capital costs, which will reach price parity at some point this decade, this is also a significant economic opportunity. So here is a marginal abatement cost curve for road transport from the Ministry for the Environment. The y-axis shows the cost to reduce each ton of emissions, and you can actually see there it's negative. So what that means is in the year 2030, we'll actually be saving money as a country by electrifying these different modes of transport. And on the x-axis is the abatement potential, up to 17 million tonnes of emissions that we can reduce by electrifying while saving money. If you actually multiply the area under the graph there, that's a $4 billion per year economic opportunity for New Zealand of money saving while reducing nearly 40% of the emissions that we need to reach net zero carbon. So an incredible win-win-win opportunity for consumers, for our economy, and for the environment. So how are we going at steps towards realizing this opportunity? You know, the good news is that EV uptake has quadrupled since the implementation of the Clean Car Discount, from roughly 500 new cars per month to now 2,000 new EVs per month, and it's continuing to rise. August there was level 4 lockdown across the whole country. That's why there was a blip. So plug-in EVs now represent 13% of new vehicle purchases. Fun fact, in September, more Tesla Model 3s were sold than Toyota Hiluxes, so that's quite amazing. And this uptake is only likely to increase as EV costs decline further, and the fee component of the rebate comes into effect in 2022. But more is possible and more is needed. So Norway has now reached over 90% of new vehicles being plug-in electric, which is quite phenomenal. Our uptake of 13% is where Norway were in 2014, 7 years ago. So what is Norway doing? You know, they have comprehensive policies targeting EV uptake that incorporate more than just tax incentives or upfront capital cost incentives. So what does the electrification roadmap propose that we do to become the Norway of the South? Well, there are 3 main areas. New Zealand's access to the global EV market so that we can get the supply into the country. Access for consumers to these vehicles, and then access to charging to charge these vehicles. So the first one, access to the global EV market. There has been some talk about the concern of the ability to get supply into the country. But actually the way to solve this is to become a market of choice through sending the right signals to global suppliers. If we demonstrate that we're really serious about electrifying our economy, suppliers of vehicles will go, okay, that's a market we should think about supplying to, and we should prioritize supplying into that market because there are strong incentives and a clear roadmap there. So we think the Clean Car Standard, which will set those emissions targets through time, plus a sunset date on the importation of ICE vehicles, will set a clear roadmap and pathway to global vehicle suppliers that will provide a strong market signal that New Zealand is transitioning towards more electrification of vehicles, and will give them the confidence that they need to bank on us as a market that they can do business in. The next is access for consumers to these vehicles. So the largest barrier here is predominantly upfront capital costs. So the rebate is the most important initiative that we need to increase EV uptake. So it's really great that it's in place. But there are also other things we can do. Innovative financing, leasing, transport as a service models that help to spread that upfront capital cost out, particularly which corporates can access as well, will help to alleviate these upfront capital cost barriers. On the operating cost side, the extension of the road user charge exemptions has been very important. A further opportunity for improvement here could be fringe benefit tax exemptions for commercial fleet EVs. And that's really important because commercial uptake, they turn over their vehicles, large commercial fleets every 3 to 4 to 5 years. And those are new EVs that just get pumped into the secondhand consumer market. And that really helps from an equity perspective for giving access to consumers who can't afford necessarily a new EV, but prefer secondhand or prefer the ability to have access to secondhand EVs will really enable greater broad-based uptake across society and across the economy. And the other one here that's also on this page is the behavioral incentives, like the use of transit lanes, etc., for EV users. The final one, access to charging. So access to electric vehicle charging and having the right electricity infrastructure in place will also be very important. And so the ECA funding is helping a lot in this area. And I'm also very confident that the electricity sector can enable a forecast 40% increase in electricity demand by 2050 due to transport electrification. So finally, if there's one thing I can leave you with, go to our website, Transpower's website, and check out the electrification roadmap. Let us know what you think, and if you have any questions, feel free to ask us. Thank you very much.
All right, good afternoon. My name is Alex. I am the head of 36KR Global. I feel extremely excited to join this event live from Beijing, and we'd like to share with you some of our thoughts and insights on the EV industry here in China that could potentially be helpful for New Zealand to develop its own low-emission vehicles and their infrastructures. Allow me a few seconds to share my PPT with you. All right. Before we jump into our detailed discussions, I'd like you to know that 36KR Global is a media as well as a research and consulting company that strive to establish the business cooperations between China and the rest of the world. We have done so in many countries so far, and I'm proud to let you know that we have established our new brand, KRANZ, in Auckland earlier this year. The brand is led by Liam and Kevin, and it is meant to serve as a gateway to a promising business collaboration between New Zealand and China. Now, when we talk about electric vehicles in China, there are a few comparisons that will help you establish a baseline to understand the whole picture here. China is definitely the largest electric vehicles market in the world. In 2020 year alone, there are 1.1 million electric vehicles sold in this country. That figure is about 30 to 40 times that in South Korea or Japan. But having said that, it doesn't mean that South Korea or Japan is anything behind China in terms of EV technologies. For example, Japan is well known for its sound manufacturing capabilities for automobiles, and has obviously chosen a very different route in terms of low emission technologies. Now, another thing that you have to understand about the EV industry in China is that this is an industry that is mostly bolstered and encouraged by the Chinese government. You can say the industry is basically created and nurtured by the Chinese government's policies, but there are shifts in terms of the policy, the emphasis of that policies. In the early stages of China's EV journey, the government's policies focused on incentivizing individuals to purchase the electric vehicles. That was back about 10 years ago. But as time went by, the policy gradually shifts to the mandates onto automobile makers. That means the Chinese government phased out their incentives for the individuals to directly purchase these vehicles, but instead put their mandate on the automobile manufacturers. For example, the Chinese government stipulates that 40% of the vehicles running on the road by the year of 2030 must be driven by electricity. Now, despite the headwinds from the global COVID-19 pandemic, the electric vehicle market continues to expand in China. If you have to talk about a few top players in China, we can divide them into three categories. The first one is the international brands like Tesla, which is well known in many countries other than China. There are traditional automobile makers, domestic automobile makers like SAIC, BAIC, and Chang'an, which joined the game a few years ago. There are new entrants like NIO and Li Auto and Xiaopeng Motors. Both three have been listed in Hong Kong and New York stock exchanges and have garnered great revenue from the Chinese markets. Nowadays, even some internet giants like Apple and Baidu and Xiaomi have been considering into breaking into this EV game. Now, behind this trend is the fact that besides the central government of China put forward its versions of policies, every city and nearly every province in China have their own versions that could bolster the adoption of electric vehicles in their own area. Now, these policies range between anything between the lift of restrictions of car plates. As you probably know, car plates are hard to get in large cities like Beijing and Shanghai nowadays in China. There are also subsidies, specific subsidies for charging, for using public charging infrastructures of the electric vehicles. Now, if you drive a car that's powered by electricity, you probably get lower costs and very likely free parking in many dense areas in the city. So now the development of China's electric vehicles cannot be achieved without the fast-growing infrastructure that supports the adoption and usage of electric vehicles today. Now, this is something we have to remember when we make the comparison between China and New Zealand in terms of EV infrastructures. Now, China has 1.6 billion people. Many of them live in very dense urban areas. That is quite different from the situation in countries like New Zealand and the United States. Now, people don't really have sufficient space to install the charging piles in their homes, but instead they resort to solutions that are closely related to public charging scenarios. Now, here are a few examples that you can check out here in this page. On your left-hand side are the charging piles that are installed by China's state grid, which are pretty common and in the everyday life of Chinese people. On the right-hand side, you see a fly line. Now, the fly line refers to an informal way to charge your vehicles. It's basically a charging cable that flies out of the window of your apartment and goes right down to the ground and onto the vehicle that you're trying to charge. I mean, this is definitely informal and in many areas illegal, but this is what happens on a daily basis in many places, especially urban places in China. And this is at least how people get their vehicles up and running. So Chinese people have come up with very creative ways to charge their vehicles. Now, that's the basis how this the whole industry can grow in a continuous manner. Now, nowadays, people don't really have to worry about running out of battery in almost all kinds of circumstances, whether it's in whether it's in ground parking lots, in your offices, in shopping malls, in public facilities, neighborhood units, or in freeway service areas. You find charging piles everywhere to have your vehicles charged at any time you want. Another example here, just to illustrate how robust the industry and the infrastructures have evolved in China. NIO, the company, have installed many charging stations along the major highways between Beijing and Shanghai that runs about 120 kilometers, and between Beijing and Shenzhen, that's more than 2,000 kilometers. So people can drive their EVs anywhere to very remote places in China without worry about running out of their batteries. Now, a few names to be mentioned about the charging operators. The market is dominated by 3 players, namely T-Good, the largest charging operator manufacturer in the world, StarCharge, as well as State Grid. There's another trend of shifting that we should mention here is that we see a major shift between the charging operators in urban cities, and then now expanding to suburban areas and eventually the rural areas. For example, before 2018, 40% of charging operators concentrate geographically in major cities like Beijing and Shanghai. But nowadays, even in remote provinces in China may have more than 1,000 charging piles in that province. Now, in terms of China's future EV outlook, we do anticipate the market continues to grow. And this is going to be an exciting market for the China's domestic players and international players alike. China expects to have, by the way, 80 million EVs running on the road by the time of 2030. Now, A few things more to mention about the battery makers. And there are two major battery providers in China. One is BYD, originally an automobile maker, now transferring to providing, the batteries to the third parties. While CATL is the world's largest battery electric vehicle battery manufacturer based in Fujian province in China. It has nailed a very lucrative deal with Tesla in China. It's a major supplier and the go-to place for many of the world's renowned EV brands. Now, a few more interesting things about battery services in China. Now, you don't really have to connect your electric vehicle to a charging pile in China. You have other ways to have your cars charged. One way is the battery swapping services that are pushed forward by NIO alone. Now, you can drive your car into a battery swapping station and have your battery changed in just a few seconds. The other way is what we have illustrated here in this page on your right-hand side. Now, NIO has a dedicated fleet that drives a Volkswagen van in and out, day in and day out throughout the cities to charge your cars wherever you are. These are creative ways that are implemented by Chinese companies to have people, to encourage people to adopt their electric vehicles. Now, last but not least, a few tips for the New Zealand's EV future from China. First of all, in terms of policy, just go further than fee bait, get creative. We do recognize that the clean car initiatives and fee bait initiatives are going to bring significant changes to the landscape, to the EV landscape in New Zealand, but there are other ways to have these initiatives becoming more creative. Now, from China's lessons, you can learn that there is a shift between the emphasis of the Chinese policies. Now, one way is to emphasize your subsidies on the consumer side. The other way is to push forward the mandates on the manufacturer side. Both have worked well in China, and this could be something that New Zealand can take away. Secondly, charging infrastructures, design the charging infrastructures for unique needs. We have mentioned that the market nature is fundamentally different in China from that in the New Zealand. Just focus on your way of designing your charging infrastructure, charging piles for your homes. Choose carefully whether you want to go down with a route about providing public charging infrastructures, because it's quite different in terms of geography and the cities and areas that are less populated in New Zealand than that in China. Now, thirdly, New Zealand do have its advantage as a late mover. For example, you can choose to adopt the latest technologies in terms of DC and AC technologies when installing your charging piles. So you can choose between technologies that are implemented in China and its neighboring countries. Just import these technologies to New Zealand, have it commercialized instead of inventing everything by ourselves. This is one of the most important late mover advantages that can help New Zealand achieve the carbon neutrality and achieve low emission goals in a very low cost manner. So these are the things that we wanted to share today. And if any questions, I would like to share in the QA session. Thank you.
Hello everyone, my name is Mahesh, and today I'm going to present on a topic of the digital and energy technologies converge innovation to build a world-leading supercharged network. We believe that this kind of infrastructure is going to ensure green and efficient ecosystem development. It will create new values for the end users, and at the same time, it is going to strengthen the cooperation amongst the ecosystem partners, and it is going to ensure the rapid development of the charging infrastructure as well as the electrical vehicle domain. So in the first point, I would like to address about what are the issues or what is the projection of electrical vehicle globally. There are some dominant markets, such as we can see on the left figure, that the China, Europe, and USA are the dominant in electrical vehicle domain. And projection by 2030, more than 131 million electrical vehicles will be in the market. Japan is the fourth player, which is behind China, Europe, and USA. So there is a boom in an electrical vehicle domain. And at the same time, when we look into the infrastructure kind of requirement, we see that the global vehicle to pile ratio is decreasing year on year. What it means? That means it is going to make life for the end user convenient in terms of the charging infrastructure. We see that initially there was a gap between the vehicle to pile ratio and the electrical vehicles, but year on year it is decreasing significantly. Such as we can see that in vehicle to pile ratio in China is 2:1, and in Japan it will be 3:1 by 2025. When we see a booming electrical infrastructure, electrical vehicle domain, there is also a need to ensure a infrastructure related to the charging development. So in these scenarios, we see that there is a projection of more than 1.74 million DC charging piles construction worldwide by the year 2025. Most of them will be dominantly in the areas such as China, Europe, and Japan. So this is going to be an outlook of the rapid growth of the electrical vehicle domain and how is the infrastructure is coping with this rapid boom. Second outlook, we are looking deep into what is the segmentation of this electrical vehicle. So the private electrical vehicles will account for the 85% by 2025. More than a just number or a percentage, what this figure means to us. This figure means to us that the dominant scenarios will be residential, campus, and even to the last mile, because you need to cope up with these private electrical vehicles, which are distributed in every kind of segment. That is to say, a large kind of deployment will happen in the charging infrastructure. This is going to be a definite case by year 2025. So the figures are telling you a different kind of correlated reflective stories also, right? And on the other part, we will see that what are the issues concerning to the end users normally. So the end users are having some issues related to the inconvenient charging and so on. So the problems the end users is facing is related to the inconvenient charging. So 56%, that is a huge chunk of their problems, are related to inconvenient charging. Along with that, battery life, slow charging, and charging time, and so on, that are associated drawbacks also. So when we move to a charging infrastructure, we need to take into account one important point is that the charging infrastructure will have a significant kind of deployment by year 2025, and it has to comply with some of the end users kind of pain points. So we had to look into what is the existing status of charging infrastructure and how we would like to meet with the new challenges and so on. So when we look into the charging infrastructure, it consists of two drawbacks. First of all, the industry chain is large, it lacks intelligence, and other than that, in the entire life cycle, you have associated pain points. That is not an efficient way to cope up with the electrical vehicle boom. That is to say, in the design, construction, running, and the operation and maintenance, there are associated drawbacks, such as difficult construction, you require a large footprint, initial investment is much more high, poor user experience, the slow charging capabilities, and the noise produced by some kind of the charging cabinets and so on, which will make them difficult to adapt to a quiet residential scenarios. Operating profit margins are lower because of the heavy losses incurred and so on. And the operation and maintenance is mainly manual, and there is a lot of fault occurring. That is impacting your operating cost, and also the O&M is much more difficult. And yet you need to cope up with the new requirement. That is to say, for example, 120 kilowatt charging, now you need to move to 300 kilowatt charging. So how we want to perceive this kind of transition of a charging infrastructure? So definitely we need to overcome the difficulties, which are difficult construction, low operating margin, O&M cost, and lacking intelligence, and so on. So when we move from the charging station 1.0 migrating to the charging station 2.0, we see two important changes. The number of players are going to increase because a massive rollout will happen in the future to cope up with the rapid boom of electrical vehicles. It is going to ensure the ultimate charging experience. Smooth evolution will happen. It is going to be highly efficient so that the losses will be minimized. It will be a green kind of construction, and it is going to provide the ultimate security and reliability. So let's look into how the future charging infrastructure is going to look like. So basically, we are looking in a complete cohesive picture here. First of all, it is going to be the convergence of two infrastructure. One is an energy infrastructure, and second is an internet infrastructure. And on the top, it is going to have value additions. These value additions are related to some of the features that are bringing the grid friendliness, digitalization, utilization of the PV storage, because the carbon neutral is one of the important moment. We need to adapt to the renewable energy as much as possible. For the security and reliability, we have a zero accident kind of mechanism. Improved cooling techniques will be utilized in order to provide more than 10 years of lifespan. We need to look into account a flexible evolution. So the next 10 years of the rapid deployment, we can cope up with reshuffling the entire infrastructure. Of course, with a carbon neutral, green and efficient will be one of the key DNA. We need to have some innovative techniques in order to reduce the energy consumption and so on. One important aspect we need to look into account is that the anxiety or phobia of end users for the using electrical vehicles, we need to avoid. So some of the innovative approach such as plug and play charging system, code-free payment, and prior fault warning kind of systems will come into the picture. This is how we are going to have the intelligent collaboration between the vehicle charging piles and the network to build a smart charging network for the future. And as in the beginning, Alex, Derek, they have all mentioned that the charging scenarios is going to be universal. It is going to be ubiquitous, right? So you need to have a different scenarios, different requirement. There will be different kind of cars and so on, which requires different voltage. So all scenario charging you have to cover. So how we can ensure anytime, anywhere charging is possible for the end users. So this is our solution which we are going to forsake in the future, that the large amount of charging portfolio we are going to cover. That is going to have the home-based charging for the private electrical vehicles, smart and convenient charging, a fast DC charging kind of mechanisms, and the centralized construction sites that can help you to ensure the ultimate charging experience and so on. Anytime, anywhere charging capabilities is definitely going to overcome the problem, which is inconvenient charging, which we have seen in the first point. So when we look into what is our projection for the future, we have a comprehensive cutting-edge roadmap that is going to ensure end-to-end solution that is going to assist you with a different kind of scenarios. So we are going to have the different products that are going to be launched in the coming year that is going to fulfill the need of rapid development of the electrical vehicles. So intelligent charging network, fast charging capabilities, DC split pile, which is providing you 400 kilowatt of the capabilities and so on. These are the innovative products we are going to launch in the coming future. It will be modular, efficient, and these kind of products are going to definitely make sure that the charging infrastructure is going to have a rapid kind of transformation to meet the boom of electrical vehicle domain. This is how we can flourish together this electrical vehicle industry. That's all with my short session. And in latter part, for the question and answer session, if you have any question, I will be glad to answer them. Thanks a lot. It was a pleasure to talk with you during this event. Thank you very much.
Thank you very much, Mahesh, and thank you all of our panelists. Can I please ask you all you turn on your video, and we are now moving to Q&A sessions. Thank you. I can see there are numbers of very popular questions from the Slido. I will just asking a few very popular ones first. I believe first one will go to Derek on the electronic bus. So are electronic bus going to impact on AT's ability to provide a reliable transport system? For example, how will you avoid buses running out of a battery on the road?
Very good question, and this is one of the key reasons why we decided that it was important to run a long and number of electric bus trials to understand their operational performance and assess what intervention, if any, will be required in order to ensure that the reliability of services and customer experience is not interrupted. In fact, it should be improved. So we have done the simulation in terms of how many bus services would be fully operated, even if buses degrade to 80%, and assuming that buses will be returned to depot with a minimum 10% reserves should they require emergency kind of return to depot. The study showed 88% of our bus services will be operating without any such interruption. And the key for that is also important that the key importance is that our depots have uninterrupted power supply in order to ensure that the vast number of fleets get charged fully before they leave in the morning. So we've been working with our colleagues at Vector, in particular to ensure that when we design depot connections with high voltage network, we have redundancy built in. So if one part of the network goes offline, we have several minutes to switch onto another feed to ensure uninterrupted power supply. We are also looking to, in the future, to use the buses that will no longer be required for bus fleets, but will still be in good condition to provide stationary battery storage, and use them to provide additional resilience and redundancy within depots, not only to provide reserve power, but also when demand increases to reduce further reinforcements of electricity network. So we could actually more constantly charge those booster batteries and then use them to charge buses. So overall, that's kind of our approach to ensure that the reliability of buses is not interrupted. In fact, should be even improving customer experience. Thank you.
Thank you, Derek. I do see a lot of questions come from Slidos and also some of the participants in our chat in the Zoom. And there's a number of questions related to the electricity demand, or probably I'm sure this will relate to Richard. So I will try to combine all the questions together. They're all on the same topic. So question to Richard. So how will we meet the growing demand for the electricity? Will there be a significant increase in electricity price? And then to illustrate that there are many of new car owners. For example, there's one question for the friends at the Tesla just installed at home. You will see a high demand from domestic electricity demand. So how we, as a national grid, how we see this coming through, and how we try to also how can we try to keep the supply, but also is there any impact on our price? Richard.
Yeah, good questions. The increase, so from electrification of transport, we predicted that will increase electricity demand by about 40% by 2050. So it's about a 1% increase year on year for the next 30 years compounded. So in that context, it's not actually huge. Certainly in the next few years, it's even less than that. It might be, let me just have a really quick look to see what those numbers might be. It could be about, yeah, not too much by 2030, like less, less than 10% increase in electricity demand. So it's definitely doable. How will we supply it? Well, we have a market that incentivizes this, the development of new generation. There is a lot of new generation inquiries that we're receiving because we connect up the generation. We don't actually generate, and we're just receiving at the moment more than we've ever received before. We used to receive about 5 on average a year. Last year we received about 60, and this year we're on track to receive somewhere between 150 and 200. So the interest in new generation is increasing significantly, and the good thing is the cost for new generation is declining rapidly through the rapid decline in costs for wind, solar, and storage in the form of batteries. So I think the story is we should be able to do it, and we should be able to do it without significant increases in prices. To the contrary, we should be able to actually have better prices with the build out of lower cost generation. The main challenge is meeting the peaks. And what will be key there is having smart charging and time of use pricing that incentivizes charging to occur outside the hours of 5 to 8 p.m. on a cold winter evening. And that will be the most critical point for ensuring electricity can meet the supply.
Thank you, Richard. For the next question, there are a few questions about battery swap services. I'll direct the question to Alex first and then to Derek about the AT's bus battery swap. Alex, battery swapping services sounds really good. Are there any global players doing this as well? And is there any difference?
All right. About the battery swapping. Okay, so there are a few manufacturers that are considering providing the battery swapping services. In China, this is basically carried out by the automaker NIO, and we've been told that players like Tesla, are considering such similar schemes in China. About the question on the battery swapping, I think there are a few reasons why Chinese people have chosen this way of charging their vehicles, or why this kind of business model can survive in China. Now, the first one is about purchasing price. For example, if you want to buy a NIO car in China, you have two ways of buying. First of all, you buy an entire car. That's a EV vehicle, that's electric vehicle with its batteries that is belong to you. Now, another way is you buy the vehicle without the batteries. Now, that will save you about 120K in RMB. That's about 28,000 New Zealand dollars, and about a quarter of the price that you have to pay for the entire car. So just consider, if you buy a car with 75% of discount, if you choose to buy the car without the battery, and then pay about 2,000 New Zealand dollars on a yearly basis to have the battery swapping services. That's a great deal for many people. Now, the second reason has something to do with the standard of the batteries. Now, consider if you want to implement the battery swapping in large scale, you wish to have all batteries exactly produced in the same size with the same charging technologies. Now, in China, this has been achieved by the government, largely by the government's efforts. Instead of all kinds of automakers rolling out their own versions of batteries, the Chinese government chose to sit down with some of the largest EV makers, NIO, for example, to map out a set of standards that the EV makers should adopt when manufacturing their batteries. Now, this way, the battery swapping business model has become a possible way of charging your cars. Now, the third thing I think has something to do with the charging speed. At the moment, battery swapping is way quicker than charging your batteries with a charging pile. It takes just a few minutes to replace a spent battery with a full charged one. And again, this has something to do with the charging scenarios in China. Like I mentioned, people don't really have a lot of charging piles installed in their homes. So if you want to resort to public charging solutions, having your batteries swapped in some places is definitely one of the choices that you can opt for. So these are the three reasons I think why this is popular in China and not in many other countries. And I hope that gives some insights about this business sector. Thank you.
Thank you, Alex. Derek, just to follow up to this question, there's a question asking, has AT considered a sweeping station for our buses on the road?
Yeah, good question. We certainly have looked into it, but the simple answer is no, we don't consider this as part of a future roadmap. There are a couple of reasons for it. We are aware that this has been tested and is being done by one operator in India, as an example. But we have discussed this with a number of bus suppliers to New Zealand market, and there are some complications with the swapping very large and heavy electric buses. It's electric bus batteries, which are typically built and located on top of the roof. They are quite large packs. They typically water cooled, and they come with the fire suppression system that requires certain certifications and setup. So the swapping system will be definitely quite complex. Would have to comply with our working at heights regulations, and the time to swap would be quite complex, and resetting and reconfiguring the fire suppression system, for example, to ensure ongoing safety would be quite time consuming. Our buses are operated from 22 different depots, and they all have a different setup and different skill set within the workforce. And there would be a risk of achieving that consistency that Alex mentioned is quite important when you do quick swaps on something that is relatively simple. So for buses, now we have looked at it. It was a very interesting concept, and we looked at this very early when we thought whether it would be better to continue to look at hydrogen fuel cells as alternative fuel source or energy storage for longer routes and long operating hours, or maybe with time, as the battery technology improves and the weight of buses also get lighter as the assembly and construction also gets better, and more powerful battery pack may actually give us that additional distance that may be at risk for some services. So this is kind of where we have chosen to go. Hope that answers the question.
Thank you, Derek. There are two questions for John. They both come from Slido and the chat in the Zoom. I'll just try to combine them together. So John, can you quantify the production level? Will you be able to supply a major manufacturer for the instance through the period to 2050? And another question is actually, during your production, is there a byproduct or downside on the pollution on the path? Can you please? Thank you.
Certainly, Wei. Look, on the first question, most people in the lithium space actually supply a cathode manufacturer as a component of the battery manufacturer. So a small cathode manufacturer might need around 5,000 tons per annum of lithium carbonate, and a big one, 20, 40, 60,000 tons. For us, our first plant will be a modest one, might be a couple of thousand tons of lithium carbonate equivalent per annum, and we want to move pretty quickly to the large site at about 20,000 tons. So, and of course, the challenge for us is how many sites we can build. So we do hope that we can play a role alongside the other folks chasing lithium and meeting that demand forecast, which is a big challenge, right? At this stage, all of the brine sources and all of the hard rock sources will not supply the global demand for lithium. So it's a space in which we hope there will be many winners, and even then, the market will probably be short. Just on the second question, we're very anxious to make sure in our process, in our direct lithium extraction process, that we don't have nasty byproducts. We don't want solvents or other materials going back into aquifers. We're very passionate about that. By way of example, our silica process has no byproducts going back down underground. We simply selectively remove the silica from the geothermal fluid and don't touch anything else. And our approach with lithium is very much the same. A source of green lithium is incredibly important in a decarbonised future.
Thank you, John. Mahesh, even for me, it's quite interesting for me to hear that Huawei actually involved in the EV sector. So there are a couple of questions from both Slido and in the chat. That can you just first question is there's a question from the chat room. Will Huawei be able to recharge all current makes of the EVs? And if you can or you can't, then what's your products look like?
Okay, so for this, we have the range of exciting products that are going to ensure anytime, anywhere charging capabilities of the electrical vehicles. So from the AC to the DC charging and to the 400 kilowatt charging portfolio that we are going to launch in the coming year. So by the Q1, Q2, and Q3, we have the range of the exciting products that can help you to ensure anywhere, anytime charging can be possible of the electrical vehicle. And we also adopt some kind of techniques to ensure the supercharge kind of capabilities so that within the faster time, we can ensure that the SOC compliance is met. So we take into account each and every consideration for the different kind of vehicles that are adopting at different voltages so that a full scenario of a charging portfolio we are going to launch in the coming year. And it will be between the Q1 and the Q3 of the 2022. We will have this range of products in the New Zealand market. I hope that answers the question, sir.
Thank you, Mahesh. There is a question related to on the motorway, how we can assure that we have enough charging stations on the motorway and the urban cities for the long distance traveling. I will direct this question to Richard first, and then welcome everybody from the panel to join as well.
It's a good question. We've been thinking about this quite a bit because if you drive along the motorways, the state highways in New Zealand, you tend to see a lot of big transmission lines and often transmission substations. We've sort of have been thinking about, could that be one option to ensure that there is charging provided right along the different state highways. And we've been speaking to ECA about that, and I know that they're working through their low emissions transport fund to look at options. There are of course other options where, not far off the state highway, there will be local distribution networks and local distribution infrastructure that will be able to service that as well. I think it's an interesting use case because we believe it's one of the critical ones where it's probably, you probably have, from the experience in Norway, we understand you get about 85% of charging occurs in the home, 10% occurs in and around urban areas and at supermarkets, etc. And about 5% is on state highways. But despite only representing 5% of the charging, it's one of the biggest barriers. It represents a much greater percentage in terms of barriers. So it's something that we are going to have to solve. And I think through that ECA funding, they are looking quite tactically at how they can, or actually more strategically, at how they can roll that out for a national set of infrastructure along highways.
Thank you, Richard. Presumably there's no more comments from the topic. I will move to the next one. So this one is very interesting. I'm sure it's basically related to there's numbers of questions related to the battery. I'll probably redirect this back to Alex and John, and happy for everyone to join after this as well. So Alex, you compared, you mentioned the strategy for the swapping from the battery swapping from nail, and I understand that Tesla are working on rapid recharging existing batteries. Can you make some comments on that and follow on these questions for the battery, both Alex and John? What is the maturity of the battery recycling like to enable ongoing use of the battery components? And basically how long we can use the battery and then what's the recycling period? Thank you.
All right, that's a good question on the battery recycling. Now, the situation doesn't look good, as I have to say, as the EV industry scales. At the moment, there are less than 10% of end-of-use batteries in China that are properly recycled or reused. But China is now looking at I think about 200,000 tons of batteries, end-of-use batteries in the year 2020, and that figure is expected to grow significantly by the year of 2025. I mean, that's a big headache for the Chinese government and for many governments alike. About the comparison that you want to draw between NIO and Tesla, we haven't seen anything that are carried out by NIO, like battery swapping, anything similar, any similar maneuvers by Tesla in the Chinese market. But there are rumors about their plans to do, very similar things to that of NIO. But even for NIO, they have about a few hundred of these battery swapping stations all across China. But I mean, that's definitely not the only solution to the charging, to supplement the charging piles. As I mentioned, they have fleets to help you charge wherever you are. They have the delivery services that people will come to your house and drive your EV cars to, have it charged for you. Different ways of, commercial scenarios have been tested out in this country, and there is definitely not a winner coming out anytime soon. Yeah.
Thank you very much. I'm sorry we had to cut this Q&A session short. It's been really popular on the Q&A session, and I'm sure we will redirect all the questions to our panelists and then try to come back to you with either emails or communications. Now I will hand over to Claire to introduce Minister Wu.
Hi, good evening, Minister. So we'd like to welcome the Minister of Transport, Michael Wood. He is a Member of Parliament for the Mount Roskill electorate. He's the Minister of Transport, Minister of Workplace Relations and Safety, and he's also the Deputy Leader of the House. So the Minister was first elected to Parliament at the 2016 Mount Roskill by-election. In opposition, he was Labour's spokesperson for Transport, Revenue, Consumer Affairs, and after the 2017 election, he was appointed as Parliamentary Undersecretary to the Minister for Ethnic Communities and became Chair of the Finance and Expenditure Select Committee. He became the Labour Party Senior Whip in mid-2019. So the Minister also has a particular interest in Auckland's urban development and is a keen supporter of more high quality affordable housing and rapid public transport in his electorate and across the city. So we welcome you here tonight, Minister. After this session, we'll do a bit of a Q&A if that's okay. Thank you.
Thank you. Kia ora koutou katoa. Thank you very much for the introduction, Claire. And can I just firstly acknowledge Infrastructure New Zealand and all of your team for pulling this event together. Can I acknowledge the other panelists? So I'm sure have been providing some really good information over the course of your discussions this afternoon, and also China Construction Bank, who are obviously playing a key role in bringing this gathering together. Look, I'm really pleased to be here with you today to have this discussion, because we're at a really crucial point in terms of New Zealand's journey to decarbonise our transport system. And the work that we do to help shift our fleet of vehicles away from the internal combustion engine model that we've had for close on 100 years in this country to cleaner forms of transport is a critical part of that. It's not the only part, but it's a critical part. Those of you who are interested in this area, and I suspect that many of you on this call are, will have paid keen interest to the release of the emissions reduction plan that came out last week, which sets out the whole of government approach to how we meet our Paris goals. That is to do everything that we can to limit climate change to no more than 1.5 degrees by 2050. In the transport space, we have an enormous role to play. We're around about 20% of New Zealand's net emissions. around about 43% of New Zealand's CO2 emissions. But the figure that in some ways is the most challenging aren't those raw numbers. It's the trajectory that we have been on. And that's because since 1990, the emissions coming out of the transport sector in New Zealand have increased by 90%. That's 90%. And that is far and away the steepest increase of any sector. And so if we want to turn that round and have a reduction of around about the 40% mark by 2035, which is what the Commission tells us we have to do, and a complete decarbonisation by 2050, we have to start pulling all of the levers. In the transport space, that's about three big things. It's about how we avoid emissions by managing our urban growth in the years to come in such a way that people don't need to emit so much to live, to go to work, to go to school, and all of those things. That's about how we develop our growing cities. We need to also be supporting people to shift the way that they travel around our cities and regions by providing more options, good quality public transport, main trunk mass transit, great and safe walking and cycling for people. And we do know, and the evidence is very strong, that when we provide that, a good number of people will shift. But critically, we know that transitioning our vehicle fleet is an absolutely key part of how we achieve our goals as well. And we will not achieve our goals unless we do transition our fleet. So this has been a real focus of our government in the ERP, but also, as you will have seen, in the work that we have done leading up to the ERP, where we've had a really big focus in this area. New Zealand does have a very heavy reliance currently on fossil fuels for transport. Electricity and biofuels are less than 0.1% of the transport fuels used in New Zealand. And compared to many other countries, the countries with which we would generally compare ourselves to, we've had relatively poor fuel economy and poor carbon emissions profiles of the vehicles that have been coming into our fleet in recent years. But we believe that we really can move forward on this, and we've got to do so with some urgency. Every year that we delay action means that there is more to do in the subsequent years between now and 2050, and that's why you've seen us get on with many key policies already. You will be well aware that over the course of this year we've announced a clean car package that's made up of two big policies. One is a clean car standard, which effectively incentivises importers to bring in a cleaner fleet to New Zealand. And then the other is the clean car discount policy, which provides a discount for the very cleanest vehicles, pure EVs, plug-in hybrids, and some of the very cleanest petrol vehicles in the first instance, but also provides disincentives on the dirtiest vehicles coming into the fleet as well. This is a really important policy. We've been one of the few countries that don't have it. And one of the reasons I just want to dwell on this at the beginning is because I want to demonstrate that when we do take decisive action in this area, we can actually have some very, very clear results. And so I'm just going to, if you'll bear with me for a second, share my screen with you with some very up-to-date information about the impact of the Clean Car Standards discount policy since we have brought it in. So just bear with me as I work my way through that. So what you're seeing emerging on your screen at the moment is a graph of the, hopefully, can people see that now? Is a graph of the electric vehicle imports coming into New Zealand's fleet going back to 2016. The final 3 months on this graph are the months of July, August, and September. The clean car discount commenced on the 1st of July. And so what we have seen very, very quickly is a response from New Zealanders that when we start to address some of the barriers that in the past have held people back from buying cleaner vehicles, they will respond very strongly. We're seeing very clear market signals in other ways as well, that both consumers and importers and retailers are beginning to respond to these policies and are really gearing up to both bring in, sell and buy more clean vehicles, and in particular EVs, into our fleet. For the first time ever in the last month, the largest selling new vehicle in New Zealand was an electric vehicle, and that's a direct result of these policies. But what's more important is not just that, it's the why. And I'll just flick to the next slide here. This is the why. We're not bringing in policies to increase the uptake of EVs just because that's a nice thing to do. We're doing it because we're on a mission to drive down our emissions. This is a graph which shows the average emissions of the new vehicle fleet coming into New Zealand month by month, going back to 2010. And you'll see what's happened there over the last 3 months, that we have had a drop of 15% in the average emissions of new fleet coming into New Zealand since the Clean Car Standard policy commenced. That has already brought us down to the indicative 2023 target in the Clean Car Standard that many people said would be very difficult to achieve. It took us previously 8 years to achieve a 15% reduction in average emissions across new fleet coming in. We've achieved it in 3 months with this policy. Now that's early days and things might move around a little bit, but it's a very clear indication, as I say, that policies to incentivize cleaner vehicles work, and that when we provide those policies, Kiwis are responding very, very strongly. So that's why I'm enthusiastic about this event, because I know that many of you in this space are keen to be addressing some of the other barriers that might be just holding people back from taking the dive into getting a cleaner vehicle. We do know that a good, well-distributed public charging network is an absolutely essential part of people having the confidence to move towards a cleaner vehicle, an electric vehicle. We know that while the vast majority of EV drivers will charge their vehicles at home overnight, that reliable public charging network is absolutely essential to give them the confidence that longer trips are going to be viable for them. Even if they don't take those trips all that often, they want to know that they'll be able to do so when they can, to have the confidence to make the change. And of course, we do have a growing number of people, particularly in our metro centres, who live in apartments and other types of housing that don't necessarily have easy access to overnight charging as well. So that public charging network is exceptionally important. And as we get a greater uptake of EVs, and we're well on our way there, we are going to need to continue to grow and improve the national EV charging network. The good news here is that we've got a very, very solid base to begin from. We now have 97% of the state highway network within 75 kilometres of a public charging station. Quite often when I tell people that, they don't quite believe it. And when my officials first told me that, I didn't quite believe it, but I got them to show me the maps, and it's right. 97% of the state highway network is now within 75 kilometres of a public charging station. So we've got a really good basic framework from which we can build out. By the end of last year, we had 247 rapid or fast chargers and 163 destination or slow chargers that met the standards needed to be listed on the Waka Kotahi's EV Roam platform. Since July, the government's work around light EV charging infrastructure has been brought together into a cross-agency work program. So we now have Waka Kotahi, the Ministry of Transport, ECA and MB all working together on both the short-term and long-term strategy that we need for the public charging network. We don't want different agencies to be working in silos. So they are working together, and ministers, in particular Minister Woods and myself, easy to get confused, are working together very closely on this issue. They've been working to develop a national EV charging infrastructure system. That's going to also include improved EV signage, and as a part of it, we'll be reviewing targets for EV charging infrastructure. Public charging, as I think most of you will know, has been a real focus for the government's Low Energy Vehicles Contestable Fund, which has now changed name to the Low Energy Transport Fund. That's administered by ECA. They've now had 10 rounds under the previous policy, and through that, they've co-funded more than 1,100 EV chargers around the country. 700 of those are now operational, with the remainder largely under construction. So we've made really good progress in a relatively short period of time. And that's largely what's contributed to that state highway network. As part of the government's commitment to decarbonising the sector, funding for the Low Energy Transport Fund was increased in the budget this year. And that funding will now reach up to $25 million per year from 23-24, with the government increasing our contributions every year up to that point. The New Look Low Energy Transport Fund is now going to have rounds that are specifically focused on charging infrastructure. So previously the rounds are sort of open to a range of proposals, including charging infrastructure, demonstration technology, and other innovative projects. We're going to break it down and make it a bit clearer now, and there'll be specific rounds which are focused on charging infrastructure. And initially there's going to be $4 million available in co-funding in those rounds for eligible projects. So I encourage people to keep their eyes out for that. ECA are going to shortly launch public consultation on EV charging infrastructure development over the next 5 years or so. We want to really set up a roadmap so that people can see what's being planned, and that's both for the sector, it's both for industry to engage around how we roll out this network, and it's also about providing that public confidence that there is a plan in place and people can go forward and make their purchasing decisions with that confidence that it is being developed. So I really look forward to engaging with you around that. One thing within that I think is worth working through is that a lot of the investment to date, and I think it's been appropriate at this earlier stage, has been publicly led investment. We continue to have that funding available through ECA, but we want this to ultimately be a very sustainable sector, and that is going to require both public but increasingly private investment, and I think there are some real opportunities there. Moving on to road user charges, which I know will be a topic of interest for a number of you as well. Now, with the development of vehicle technology, including EVs, hydrogen and biofuels, we're making good progress in terms of how we decarbonise the fleet. But it does mean some changes in terms of how our system runs, because as most of you will be aware, we largely fund our land transport system out of fuel excise duty and road user charge, which are levied when people fill up their vehicles with petrol or diesel. So we've got some work to do as our fleet transitions in terms of how we continue to have a sustainable funding base for our land transport sector. You will be aware that we have recently extended the exemption for light electric vehicles through to 2024 as an additional incentive for people to take up that opportunity. That is not something that will be sustainable to do in the long run, particularly as EV numbers do begin to build. So we do have work that is getting underway in terms of the long-term funding of the land transport system that I'll look forward to engaging with you around. But in the meantime, that exemption will run through till 2024. More broadly, our road user charge system has served New Zealand really well. It was established in the 1970s. It had one major review back in 2012, but even in the space of the 9 years since then, a large number of things have changed. As a result of that, I've been working with officials at the Ministry of Transport on a discussion document that will be shortly released to you and other people in the sector to look at how we take that system forward, to have a sustainable funding base for transport, but in which we take account of the EV revolution, both in light vehicles and also where we see things going in the heavy vehicle fleet, where clearly there's a bit more work to be done, but we're going to increasingly see electrification and hydrogen options coming through as well. We want to get the balance right between sustainable funding, but also having the support and incentives in place to make sure that we get these technologies well embedded. So I encourage you to keep your eyes out for that. That consultation document will be likely coming out a little bit later on in the year, and I look forward to your feedback there as well. Outside of light and heavy land transport, the government is looking right across the transport sector for opportunities to reduce emissions, and that also includes in our ferry fleet. So recently you might have seen announcements from Kiwi Rail that they're purchasing 2 new large rail-enabled ferries to replace the current ageing ferries on the Cook Strait. The new ferries are expected to arrive in New Zealand in around 2025 or 2026, and they're a really important way of us providing safe, resilient rail and passenger services across the Cook Strait. They have a huge part to play in the tourism industry, but actually are also really vital in terms of the broader supply chain and the flow of freight between the North Island and South Island. The new ferries, when they are running at full capacity, will pretty much double the capacity that we can take in terms of passengers and commercial and passenger vehicles when compared to the current fleet. And critically, for the purpose of this discussion, the greater efficiency of these new ferries will reduce our carbon emissions by around about 40%. And that's through innovations in the new ferries like battery power for manoeuvring when the ferries come into harbour. And they're also future-proof for the development of future fuel sources, so that as other technologies, whether it's battery technology or hydrogen technology, develop and become more reliable for large ferries over time, we do have the optionality to change the fuel source for these ferries as well. On smaller ferries, we're also seeing a move towards zero emission options popping up around the country. The country's first electric passenger ferry is currently being completed in Wellington and will be heading out for its first sea trials. I've been to visit it. It's a fully electric high performance passenger ferry. It's the first one of its kind to be developed in the Southern Hemisphere, entirely New Zealand built over at Petone by the Wellington Electric Boat Building Company for the local East by West company. So really encouraging there. And I think we're going to actually see a relatively rapid shift in the smaller passenger ferry fleet, which can be quite significant emitters. More work to be done there, but that's looking very promising. Look, in concluding, can I thank everyone here for your interest in how we move forward with decarbonising transport. I think it's one of the most significant challenges and opportunities that we face as a country, and something that I often think about in amongst all of the other decisions that I have to make in my role as Minister of Transport, is that I think, the one question that my kids or grandkids will ask me in 30 years' time is, what did you actually do to tackle the climate emergency? What did you actually do to prevent the emergency that is bearing down upon our world? So there are very few jobs that are more important than this job of decarbonising transport. There are huge opportunities if we get it right, not just to reduce emissions, but to make life better in other ways, to clean up the air that our people breathe, to make our city streets safer, to reduce congestion, and have a better, more efficient freight system. So I really look forward to working with you on how we make sure we get the supporting infrastructure right to continue moving forward in this area and to build on our progress. Thanks very much for listening, and very happy to take any questions that you may have. Nō reira, tēnā koutou, tēnā tātou katoa.
Hi, good evening, Minister. Thank you for that. We've got quite a lot of questions, so I'll start firing them at you if that's okay. Are there any thoughts on how to enhance the infrastructure of the EV or LEV to enable day-to-day use for anyone, not only to travel from the home or the office?
So I'm not quite following the question there. Can you just repeat that one?
Are there any thoughts, whoops, hold on. Are there any thoughts on how to enhance the infrastructure of EV vehicles to enable day use for anyone, not only traveling from the home to the office?
Yeah. So look, I think what's being asked there is relates to how do we make sure that there is a really good distributed network available to people that gives them the flexibility for day use if they haven't been able to charge up overnight. And so look, the answer to that is yes, that's part of the strategy work that I said that we've got underway between the Ministry of Transport and ECA at the moment. And it's a really critical part of both, I think, individuals and corporates having the confidence to be able to invest. And I think the other thing is that if we get this right, there are some really good gains to be made, particularly for purchases of fleet. I'm seeing a lot of smart companies at the moment who are making the shift from very large and underutilized fleets to smaller fleets that can be used more nimbly, but you have to have the appropriate infrastructure in place to make sure that they're always going to be ready to go if someone goes downstairs to the basement car park to nip off for a job. So I think this is going to be a case of, yes, government having a clear strategy in place, but really partnering up with the private sector to make sure that we're drawing off your knowledge to be making sure that the infrastructure is getting built in the right places to enable that kind of mobility.
Great, thank you. Here's another one. He's obviously a classic car expert or enthusiast. Is the long-term goal to remove older cars off the road for good or reduce their day-to-day use? Is there support to convert, for instance, my 1972 Mini from its current petrol engine to an EV motor?
Look, those classic cars are absolute beauties, and I wouldn't want to see them disappear at all. And look, in the end, they're a relatively small portion of the New Zealand car market, and that's not where the carbon reduction potential is. So actually, in most of these policies, we have put in place specific exemptions for genuine classic cars because we don't want to take away that part of our culture and history. But what I will say is that there are actually a number of very smart people around the country who are converting classic vehicles into electric powered vehicles, and with some absolutely fantastic results, and it's actually enabling them to use them more regularly as well. So that's an opportunity that's out there, but it's not one that will particularly be forcing upon anyone who's got a beautiful old classic car.
Okay, great, Minister. What is the government or the Ministry of Transport doing to ensure New Zealand doesn't fall behind in terms of uptake of new technology?
Well, look, this is absolutely critical, and one of my reflections is that we did fall behind. Our uptake of EVs up till this point has been incredibly sluggish compared to most countries that we compare ourselves to, and our overall fleet is dirtier than most countries that we would normally compare ourselves to. And so our work now is about absolutely shifting gears away from that and really taking up the opportunities as fast as we can. So I think it's about a couple of key things. One is we do have to have the funding coming in behind. So that's where you're seeing us really leveraging ECA for things like charging infrastructure, for demonstration technology. We're getting some really good hydrogen projects, both in commercial heavy vehicles and buses at the moment, for example, that have got ECA support coming in behind. But sitting alongside each of those, we have to have the supporting infrastructure and technology. And so we're trying to make sure that we've got the funding streams there to support private enterprise where it's got good ideas. But critically, this is also going to have to be about how we build up really strong partnerships between private public, and also I think within the private sector between players as well. So I spoke, for example, earlier on today to one of New Zealand's larger heavy vehicle fleet owners, and they're talking about the infrastructure and technology challenge. And they're really plain that they're a very commercial organisation. They usually sort of stay in their own lane and do their own thing, but actually it doesn't make sense for each individual player to be investing in their own bits of supporting technology that may not be compatible. We actually need to come together and actually get a good base of infrastructure in place to support this transition. And that's where I think government can play a useful role in bringing people together.
Yeah, absolutely. Here's another one. Is the government considering increasing funding to local government to accelerate the move to zero tailpipe emissions for the public transport fleet?
Yes, we are. So this was a very clear policy that we took into the previous election, that we need to accelerate the shift to clean vehicles in the public transport fleet. And look, that's a little bit about the emissions profile. It's about a 1 to 2%. It's about 1 to 2% of the overall emissions profile in New Zealand, so it's not huge there. It is about air quality, because actually the diesel buses in inner city areas have a major impact on air quality. You look at the air sheds in Auckland and Wellington, for example. But actually, to be honest, most importantly, it's about leadership. We simply can't be nudging, encouraging, telling other people that we need to be making this transition if in the broader public sector we're not making it ourselves. And so that is why it's really important that we transition that fleet. So we've, in the first instance, put a mandate in place, which is that after 2025, it will not be permissible to purchase diesel buses for public transport usage, and that we expect the full transition to be complete to all non-carbon vehicles by 2035. So there's a window there for local government to work within. Actually, the biggest players are already marching ahead of that. Auckland and Wellington have set more ambitious targets. And we're currently working through exactly how we do it and what it will take. But we have indicated that we will come in behind with funding to support local government in that transition. But there are a range of other issues to work through. The vehicles at this point anyway do come at an upfront premium. They do require significant additional supporting infrastructure. That the charging requirement for those buses is significant. And then there's hydrogen as well. So we're just working through how that plays out in terms of who's responsible for not just the vehicles themselves, but the other infrastructure, and then how funding comes in behind there. But certainly central government will need to play its part.
Okay. Has the removal of fringe benefit tax been considered as a motivator to increase uptake of new vehicles, which will eventually flow into the second-hand market?
The point around how we incentivize commercial fleets to transition quickly is a really, really important one, because to the final point there, it is one of the best mechanisms we've got for getting vehicles, good clean vehicles, into the second-hand market. We know that many large fleets will recycle over possibly after 5 years, and we start to get large quantities of vehicles flowing through at more affordable prices into the second-hand market. So I mean that the key move there this year is around the clean car standard. You start to do the maths around an $8,000 discount on a large fleet of vehicles, and it pretty quickly starts to become compelling, particularly when you can consider that you can then fuel those vehicles at the equivalent of 30 to 40 cents per litre for the lifetime of those vehicles. FBT is another area where we have indicated that we're certainly open to considering the options there. And Minister David Parker has publicly confirmed that he's going to be conducting a broader review of fringe benefit tax settings early next year, and that will include consideration of this issue.
Oh, brilliant. Thanks, Minister. So as an e-bike and e-scooter user, I've got a question here saying, are you looking to also encourage e-bikes and micro-mobility as well?
Very much so. And I mean, in some senses, yes, we need to encourage it, but it's, the e-bikes are doing it for themselves at the moment. E-bikes are flying off the racks. More are being purchased by some margin than EVs at the moment in New Zealand. And the rate of purchase increase over the last 2 years has been very, very steep. So Kiwis are flocking to them. But I think there is more that we can do there, because they are a little bit of magic in this area, and we quite often, compared to normal bikes, I'm a normal bike user, but we find that people who would never consider using a normal bike for a whole range of reasons get on an e-bike and absolutely love it, and are prepared to then shift, if not all of their journeys, but even some of their journeys to that e-bike or to an e-scooter. So we are looking at further measures to encourage and support there. People might have noted in the emissions reduction plan that we did release last week, we've signalled that we're willing to look at possible incentives for encouraging people to get into e-bikes. And a part of that is the equity piece as well. They do come at a higher price point, which does make them difficult to access for people on lower income. So we're looking generally at what incentives would look like, but also a particular lens on how do we make it a bit fairer and easier for lower income folks to get into them. The point I'll just make alongside this one is that I think we do need to lean into support to get onto e-bikes, but actually probably as critical or more alongside that is the need to be making the investment in safe infrastructure, safe cycling infrastructure for people to use. We know that that's probably what makes the biggest difference in terms of people shifting mode and feeling safe to walk or cycle, is that there's good, safe, direct infrastructure. And that's going to be a really big piece of our work going forward as well.
That's great. And another one, Minister, if you've got time. Does the Minister see the MPS on urban development, so the removal of parking minimums, affecting EV uptake? What policies do you expect to mitigate the loss of home charging, taking into account local government policies to reduce on-street parking and to support public transport and cycle lanes?
Look, broadly speaking, the changes that have been made to the NPS are going to be extremely positive in terms of the emissions profile, because you're going to encourage a more compact urban form, which lends itself to better public transport, mass transit, walking and cycling. And that ultimately is the big play in terms of how we reduce emissions long term. That's the avoid part of the avoid, shift, improve framework. You have an urban form where people can be less reliant on having to have very long vehicle journeys to do the things that they need to do. But it does pose that challenge that you've identified there around charging infrastructure. So there is policy work that's underway at the moment. We've started conversations with a number of developers to try and find solutions here. And I think there's a way through here. It's not rocket science. We're seeing good examples coming up overseas where developers, make sure that they provide good communal facilities that people can access where they do need to charge up. And we're getting a little bit of that coming through with some of our developers here already. And I think there's probably a bit of a question about whether the market's just going to pick that up and develop good solutions, or whether there needs to be some clearer policy direction from government, and we'll work that through. So I think there was a second part of that question, which I haven't addressed, if you could maybe repeat.
You've got the home charging. It was taking into account the local government policies to reduce on-street parking and to support public transport and cycle lanes. I think you have answered it, Minister. So yeah. This is an interesting one about recycling, but does the Minister have an idea of what is going to happen to the existing internal combustion engine vehicles, and what a policy, would there be policies to recycle, or will they end up in scrapyards somewhere?
This is a really, really important point for us to work through. I spoke a lot in my opening comments about what we're doing in terms of the new fleet that's coming into New Zealand, but of course, at any point, the new fleet is a small fraction of the existing national fleet of several million vehicles which are driving on our roads. So we have to address that as well. In the ERP, we have signalled positive intent to look towards what's commonly called a scrappage scheme, or a scrap and replace scheme, which is whereby we would potentially provide incentives for people who might have dirtier vehicles at the moment to effectively trade that vehicle in, get a credit over and above the market value of that vehicle, on the basis that effectively then gets used to transition them to a cleaner vehicle, be it a hybrid, an EV, or an e-bike, or a combination of all of the above. We haven't done all the policy work on that at the moment, and that's getting underway now, and I'm talking about that with the Clean Car Leadership Group that I've established. But potentially within that, in fact, I would say it's a very good idea within that we actually do then look at the stewardship of the older vehicles. We wouldn't want to have the perverse outcome that we have bad environmental outcomes because we're scrapping a whole lot of old ICE vehicles, when actually there's potentially a lot of value in those that can be reused in a more sustainable way. So that's certainly something that I'd be keen to pick up as we develop those schemes.
Great, thank you. I'll take this as my last question to you, Minister, if that's okay, but with a reduction in fossil fuel vehicle tax, how will the government maintain infrastructure in New Zealand?
Yeah, absolutely critical question, and one that we are beginning to work through now. I've signalled that we are getting underway with policy work on what the future of revenue for our transport sector is. I think it's fair to say that probably, even as recently as a year or two ago, the feeling from officials is this was perhaps something that we would, be able to take our time with a bit, and was probably beyond 10 years away that we had before we had to seriously start bringing in a new system for funding land transport. Very clearly that's coming at us more quickly. So that policy work is beginning to get underway. Officials will begin engaging publicly and with the sector next year on where we need to move to with a sustainable funding system for land transport. I expect that work to probably take a good 2 or 3 years to work through. The current system has served us well for around about 20 years or so, a little bit longer actually, and we want to set up a good new durable system so that we can have certainty around long-term funding. It's worth saying within that as well that land transport funding is under real pressure. We've got the ongoing pressure to maintain the assets that we have, and that's getting more expensive to do because of labour, materials, other forms of cost inflation, the fact that we have more assets than we used to as well. So we're having to do that. And then there's a huge amount of pressure in terms of the need for us to build new infrastructure that supports this climate transition that we've been quite focused on today. And it's my view that we're going to struggle to do all of that transition infrastructure just out of the core funding that currently comes into the NLTF, and it's going to need additional forms of funding. You will have seen, for example, this year that we have pumped an additional $2 billion by way of a loan into the NLTF to support some of the needs. You'll be aware that there's work underway around how we use ETS revenue and how that potentially gets recycled back into the kind of infrastructure that we need to develop. Now, we haven't landed the outcomes of that, but that will be a part of the mix in terms of how we develop the land transport funding system. So we've very much clocked the issue that you've raised, and we've got the work underway now to make sure that we develop a fair and resilient system.
That's brilliant, thank you. And thanks, Minister, for your time tonight. I just want to also thank the speakers, our members, and also our sponsors, China Construction Bank, for holding this event tonight. So appreciate that. The other thing I just want to mention is that we have our conference next month on the 16th to the 19th of November, and Minister Wood is going to speak at that conference along with several of his other colleagues. So it would be great if our members tune into that as well. So thank you, and thanks everyone for staying on tonight. And thank you again, Minister. Thank you. Bye.